So, am I now visible or not? Well, I assume that I am visible, so I am going to start my little presentation on the ESP32 with Android topic. I named it Cooperation for Rich User Interfaces, and essentially this is much of what we are going to be doing during the next hour. And well, I decided to structure my talk into 4 groups. The problem is when you present electrical engineering, it's a very, very wide field of science. And so it's always a bit difficult to present everything in, like, say, 30 or 40 minutes. So I decided to break it down into 4 large blocks. First of all, a bit of a motivation, why we should look at it. Secondarily, an analysis of what the ESP32 is, what are its unique strengths, its unique weaknesses. Then a discussion of Wi-Fi, and finally a discussion of weird ideas which can add value to your project. And some of you might be missing Bluetooth, and I decided to take out the Bluetooth slides because we have Sir Woolley here, who is an expert on Bluetooth, and it would be like carrying oils to Athens. So, yeah, this is me. Probably most of you already know this slide. It's like the 50th time I'm showing this. Hanna, I own Tamogamon Holding KS. It's a consulting company. We do interesting engineering problems. And yes, this Instagram account you should follow. And wait, let me first check if you can see my slides. Everybody can see my slides? Yes, all is okay. Perfect. Then we can continue. If my old IBM lets me, that is. Yeah. Be a good girl. This is the question which we talked about. Why did I bother to get started with the ESP32 and Android cooperation? And the answer is this thing. This is an ashtray. It's not yet for sale, but it's a very, very smart ashtray. It listens to you and it changes its colors and its behaviors in reaction to various things around you. You see here the website, you can sign up for a pre-order notification. But the cool thing about the ashtray is the Android phone, which you see here. I'm circling it in red because it is connected wirelessly, and the difficult parameter settings are done on the phone. So the ashtray doesn't need a display, these tiny displays with 4 buttons, which everyone hates. No, everything works right out of the box thanks to Android. And so now to get started some more, let's look at the question, why do we need Android? A few years ago, I was at Droidcon. Back then, we could still fly. I was in Turin in the old, beautiful facility, and I presented this slide. And it's essentially a digital oscilloscope, but it uses Android, you see here, to digitize the actual data. And the developer, as you see here, obviously was a bit drunk because this is a bad idea. Because Android is not a good real-time operating system. But on the other hand, we see this guy here, and we see this is a multimeter, and it has a very, very rich user interface. So it is obvious that people now demand much more from their test equipment than they demanded, say, 5 or 10 years ago. And you also have the same trend with coffee machines. As a hobby, I run a coffee shop together with my wife and a local business guy, a drone pilot. And our coffee, the grinding mill, we have this 2-step espresso machine. The grinding mill has a 24-bit color display. Well, throwback time to motivate the problems of Android. We had this some years ago, and the solution still is Massimo Banzi's idea, but now it's taken more radical. When he originally introduced the Arduino Uno, he had this two-step process where you had a real-time unit with an 8-bit microcontroller, and you had a smart unit with a 32-bit microcontroller. And in today's situation, this part is an Android phone, which not only has a 64-bit processor, but also a touchscreen and various other things which make interaction simple. So, before we get to the next step, I always like to check for questions. Are there any questions so far? Mirko, you see any questions? No, and wait here. Maybe I get on the other PC. No, I also don't have any questions here yet. So then let us continue with the next set, which is what is the ESP32 actually all about? And the ESP32 is a wireless microcontroller. I know this term now sounds a little bit stupid, but if we look, we see here, I don't see myself. Yes. We see here, we have basically a microcontroller with all the normal hardware communication interfaces like I2C, I2S, SPI, and so on. Here we have a dual core microcontroller, and here it's going to be a bit difficult to draw with the mouse. We have a full-blown wireless transmitter. So essentially, you put the ESP32 module into your application, and it takes care of all the communication problems for you, and you don't need a second microcontroller anymore. So all the hardware intelligence comes to you essentially out of the box. And when it comes to programming the ESP32, you've got two nominal choices. As you see, first of all, we've got ESP IDF, which is what I would recommend because it lets you make the most of the power of the underlying hardware. And then secondarily, we've also got the Arduino IDE, but it's an abstraction layer, which I don't think you really need. So I'm going to be using IDF exclusively during the next presentation. And yes, of course, there are also other programming systems which can be attractive to some. Firstly, there is MicroPython, CircuitPython, all of these Python things. They do work and they do run Python on a microcontroller, but the question is if you really want to run Python on a microcontroller. And yes, this is an Italian conference, so of course I also have to make a head tip for Cerunz. They provide some kind of compiled Python environment with a much higher performance, but it costs money, and you are only allowed to use their very own custom derivative of the ESP32. And when you work with the ESP32, you need to keep in mind that there are now like 20 different ESP32 families on the market with different types of processor, different wireless modules, and so on. In practice, for you, this is not so significant because Espressif normally, they never discontinue anything. So you select something and then you just keep milking it like a cow. The only important thing is you really need to validate your bill of materials, because if your PCB assembly house happens to buy the wrong module by mistake, well, then you're in trouble. So far, any questions, any feedback? I don't see any yet. So it's time to look at the most important way of communication, which is the Wi-Fi module, which is available, of course, both in the Android phone and in the ESP32 module. Let me check if I got any questions. Here I don't see any questions. Here I don't see any questions. So I will just resume. The biggest benefit of using the Wi-Fi transmitter, of course, is that we have no certification fees. At least from the Wi-Fi SIG, we have no certification fees. And it's universally available and it works with everything. This is a significant benefit because, for example, if you have a workstation or a thin client or something like that, Bluetooth, while it is a very, very good protocol, don't get me wrong, and very, very efficient, Bluetooth, once you move away from a laptop, it's normally not available. Workstations don't have it. Whereas a workstation can easily connect to a Wi-Fi by an Ethernet cable, which you plug into the back of the router. So the benefit is that Wi-Fi essentially gives you the most universal way of communication. But the disadvantage is the power consumption is very, very high. In practice, if you use Wi-Fi in an ESP32 based system, I would suggest that you plan at minimum 250 milliampere power consumption just for the ESP32. And yes, there are, like a Janus head, there are two ways to use the ESP32's Wi-Fi module. There is either infrastructure mode or there is the normal mode. In the normal mode, the ESP32 will simply connect to a Wi-Fi access point and then will behave like a stink normal Wi-Fi client. Whereas in infrastructure mode, the ESP32 uses its little wireless transmitter to create an access point, and then the phone connects to this access point. And the benefit of this approach is that there is no need for the client to bring a router or a Wi-Fi infrastructure of his own. But of course, the disadvantage is while the phone is connected to the trinket, there is no internet access via Wi-Fi, and the user must connect manually. And to actually program the ESP32 for the Wi-Fi mode, I like to show you just a few snippets here because people often are afraid, but it's really not the case. You see here in the first case, essentially in the first step, we initialize the flash memory. And after that, we already are off to the races in terms of the Wi-Fi mode. And what's very important here when you develop for the ESP32 is this configuration script, a configuration struct, like here the CFG. Essentially, the development for most ESP32 based systems, if you use IDF, and also for the 8266, essentially it's very simple. It's like if my wife goes to the shop and she buys something. She has the little basket and she goes into the shop, into the penny, and she carries the basket and she goes, she collects an avocado, she goes on, she collects a piece of bread, she goes on and she checks out. And the configuration struct is like the little basket which you pass from the API to the API to the API. I see here Roberto Laricia. I hope I got the name right, Roberto. You asked What about the ESP8266? The ESP8266 essentially is an ESP32, which is a little bit cheaper and a lot more stupid. But the programming in general very much is the same, especially if you live in the ADF environment. So if you have a very high volume application and you want to save the last cent, why not take an ESP8266? I say nothing against it. They sell by the millions. But we in the company, me and all of my customers, we decided to use the ESP32 just also because the analog peripherals are more comfortable and stuff. Either way, back to the point, you see here the struct gets initialized in the first step, and then it will be passed on and on and on. And you see here, it gets, then you invoke the various configuration methods, and at this point, we already have the access point running. Are there any questions about this so far? I have to apologize. I get the questions, as you see over here on my second screen, which has a bit of a latency. So I am sorry, I'm a bit slow. But let's resume now looking at the Android part of the enchilada. And the Android part of the enchilada starts out with the declaration of a multitude of, capabilities or permissions nowadays. Sorry, I'm still in the Symbian world. And the reason why we need all of these capabilities is that Wi-Fi can also be used for geolocation. So we need at minimum the 4 permissions which you see here. And when it comes to actually connecting the phone to the hardware, wait, maybe I have a hardware flying around here. Yes, I do have our hardware flying around my lab. So when it comes to actually making these two people get in touch, the important thing is you need to understand that especially in the fashion and also in the lifestyle business, many users are not electrical engineers, and so they are technically challenged. And it is very important that you take them by their hand and literally you walk them until they have reached their home. And so the first step involves turning on the Wi-Fi transmitter. And of course, we are working with Google, so we have to say thank you, Google, for messing with the API. Because in Android Q, as you see here, it is no longer allowed to directly access the Wi-Fi transmitter. And so, in principle, we again need a Janus-headed pipeline. And you see here, if we are on an old phone, it's actually pretty simple. We just call set Wi-Fi enabled, we set it to true, and then we are done. And on a new phone, sadly, the situation is more difficult because on the new phone, you see here, we need to fire off an intent, and this intent then triggers a dialog on the phone, and the user has to explicitly agree. So he has again to click, yes, I want to connect. Either way, if we are connected, in the next step, we need to start scanning for devices. And it is very, very recommended that you have a bunch of labels, like here, my idiot label, which tells the user, we are now scanning, please wait. And the actual scanning is a semi-asynchronous process, and it, of course, requires the presence of a broadcast receiver. And as you see here on the screen, as you see the code on the screen, there are a few steps required, and the broadcast receiver essentially gets the call when the Wi-Fi gets discovered. And you see here, for every Wi-Fi which we discover, we call this to add it to a list. And yes, of course, the broadcast receiver needs to be registered with the operating system, as you see here on the screen. And you can do this at runtime. And then essentially you have a list of Wi-Fis, and the user will just go and will click his list of things. So now comes the second step. In the second step, we need to actually connect, and the actual connection requires from the user, again, consent on Android Q. As you see over here, you get this little list, and this list you need to agree, and you need to click it. And on Android, on old Android, you could do it programmatically, whereas on the new Android Q, you have two different approaches. The approach number one is the use of the Wi-Fi Suggest API, which is needed for the internet peering networks. So if you want to connect your phone, for example, on a train or something like that, the internet peering network, and secondarily, the network specifier, which is intended for this kind of hardware, like this here, which doesn't provide internet. And again, let us start off with the old connection process on the pre-Android Q phone. On the pre-Android Q phone, basically you create a Wi-Fi configuration object, and then you get a connection to the system service. You enable the network, and after that, you are already connected. This code down here, the at.execute, this is an async task which verifies that the device on the other hand is the right type of device, because the ESP32 is a very popular piece of hardware nowadays, and simply scanning by the MAC address is not enough anymore. So what I do is I run a little additional server on the trinket, and the first step after the Wi-Fi connection, I query the server, and only if the server gives the correct response, I proceed. Either way, the new connection process is multi-step. In the first step, we need to create a network specifier object. After that, we create a network request builder. And you see here, we remove the capability internet. This informs the this informs the Wi-Fi stack that we are dealing with a network which is an IoT network. And then in the next step, you see here, we do request network. And then here we have a callback. And if we get unavailable, then we know that our connection request was passed successfully. Are there any questions so far? I will wait for a minute for the stream to catch up. Let us see if there are any questions. No, not even on my Instagram there are any questions, so then we will continue. point, we have got the two things connected together. And now that the two things are connected together, we of course need to proceed to exchanging data. And at this point, I would suggest that you use a REST-based protocol. So you run on the ESP32 trinket a little HTTP server. The API for this is ready, it is in the SDK. And the benefit of this is pretty simple. If your API requires the use of Berkeley sockets or any kind of complex TCP IP code, you need relatively expensive developers, especially if you eventually want to outsource work such as developing for iOS. Having a REST protocol greatly reduces the total cost of ownership for you and your client. And yes, at the moment, this is it for Wi-Fi. So let's go on to the weird ideas. Because you don't always only use Wi-Fi and Bluetooth, you can also use some smart things. The main reason for this is pretty simple, that entering information on a phone is easy compared to this thing. I mean, you see, I still use a BlackBerry with a physical keyboard, so for me, touch typing is annoying, but still, trust me, it is much less annoying than having these two capacitive buttons and being beep, 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 like a Martian. And finally, Wi-Fi can be jammed. And while it is not perfectly legal if non-government operators do it, let me tell you that Wi-Fi jamming has already been done in Eastern Europe in clubs. So you might want to have a second option. And for the second option, there are multiple choices. The simplest choice, which it sounds very stupid, but I like it very much, is the use of QR codes, where you have a tiny little display. A display like this big is like $25 in quantity. I can get you a contact to a vendor, but smaller ones are even cheaper, or monochrome ones. And then the user just scans it. Or alternatively, the ESP32 can even take a camera. And either way, there are libraries for both use cases. And as said, showing a QR code on the ESP32 is a very simple task. It has been widely done already. And scanning a QR code shown on the screen of an Android phone using an ESP32 already also has been done, but not so simple, especially not at real time. But the solution I have for this is that you make it a two-step process. So basically you show a real-time camera preview and the user just has to push the analyze button when he thinks the QR code is centered, and then you run the scan. And yes, this works surprisingly well. Oh, Roberto again. Another question. I'm sorry, I only see it now. Can we use co-op to communicate with the ESP32? Yes, of course. The ESP32 has a complete Berkeley sockets implementation. You can run completely your custom protocol. You can run MQTT. You can run co-op. You can do anything. I know that there is a ready-to-go MQTT implementation because I recently had to help a friend of my former lab gypsy. She needed me to find the bug in it, and I found it. So I know there is an implementation of MQTT. I am not 100% sure that there is an implementation of co-op, but I think there is one. If you email me, at the end of the presentation, there will be my email address. I will look it up for you. Oh wait, I tried to put it in the chat. It's now in the chat, Roberto. It's tamhan at tamogemon.com. You email me there and I will get you a definite answer from Espressif, not a problem. And the second interesting thing which you should keep in mind is the use of the audio sideband. Adding audio processing, either listening or sound emission, to an ESP32 is not an expensive thing. And as I've said before, and as you see with the Wi-Fi, which is used for my BlackBerry, for example, but not for the IBM with which I'm delivering the presentation, the wireless transmission of data essentially is a solved problem. And you can use fast Fourier transform to get out spectral components from a signal. And this is a very simple yet very efficient approach, as long as you don't gang up the individual frequency bands too tightly. Wait a minute. Yes. As said, it requires a small bit of additional hardware. For receiving, the bill of material cost is less than $5. And for sending, if you play it smart, it's less than $2. And there is an evaluation board, it's called the Lyra T, and it uses an AS8388 audio baseband processor, which, if you like me don't really enjoy audio work, it's a very cheap and cheerful way to work around the problem. And yes, the actual FFT on Android, you don't have to program it by hand, because there is a library by a person called Paramson. You just load the Paramson library, then you set it up, and then literally you call the FFT function with an audio block which you get from the operating system, and you get back a ready-to-run array. Fabio, I see what you did there. I'm sorry that I put it out in 5 individual lines, but here on my workstation, I don't think if you can see it, it made a bubble out of the email address and it removed the .com. And so I thought, if it wants to be difficult, I can also be difficult. Very sorry for sending you 4 messages, Fabio. Very sorry. Won't happen again. I'm very sorry. Either way, back to the... Yes, I'm so sorry. I would give you a piece of chocolate, but sadly, if I throw it here in the lab, I only hit the test equipment or my wife sitting across the desk. So I'm sorry, I can't give you any chocolate, but if you ever come to Budapest, you will get chocolate from me for free. Either way, this essentially is the whole process. And on the ESP32, it's even simpler, because there is a library called ESP-DSP. And I have a nice 20-minute video here which explains how to use the library, how to work it, how to process data, and so on. And yes, at this point, I am very thankful for you people listening. I'm now done with my presentation, so I am waiting for any questions, as they might come or might not come. And yes, in 2022, I will be publishing a book. So if you email me now, we will have a nice pre-order rebate. It will be in cooperation with Elector, and it will also look at the Bluetooth aspect of the ESP32 in considerable detail. So, with this, I am at the end of my slides. I am very, very thankful. Now I've got an order from my moderator. My moderator says that he will have some questions for me at the end. So now I am ready and waiting for the questions.